Alright students, today we're going to be talking about half angles, and working with half angles. We've worked with double angles, we've worked with angle addition. We're going to deal with half angles now. It's basically dealing with the same type of material that we've done before. So it's not going to be very much different than what we did in trig class. It's not going to be very much different than what we've done leading into this. We will use our double angle formulas for the cosine of 2a. We had different double angle formulas for the cosine of 2a. So we will utilize them. Okay, we're going to let a equal 1/2 x. Now this x is going to be any angle. Any angle that we want, we're going to make that the value of x. And we're going to make a substitution here. Wherever we see an a, I'm going to put in an x. So we have the cosine of 2 times 1/2 x is equal to 2 cosine squared x over 2, which is the same as 1/2 x, minus the value of 1. Okay, we can either use half x or x over 2. So if we simplify, on the left hand side we have 2 times 1/2, which just takes us back to the cosine of 2x is equal to 2 cosine squared x over 2 minus the value of 1. Now simplifying this, we can add to both sides the value of 1. So we add our 1, so we have 1 plus cosine of 2x. I'm sorry, that should be just the value of x. Cosine the value of x, and that's going to be equal to cosine squared x over 2, which is a half angle, dividing by 2, we have, and I'm going to switch it around, cosine squared x over 2 is equal to 1 plus cosine of x, all divided by 2. Finalize this for the cosine of half angle, we take square root of both sides. So we're left with the cosine of any half angle x over 2 is equal to, got to remember we have plus or minus since we physically did the square root, 1 plus cosine of x divided by 2. So this is your cosine of your half angle. Looking at your other double angle formula for the cosine of 2a, how else we can call the cosine of 2a? If it's 1 minus 2 sine squared of a. We also still had cosine of 2a is equal to cosine squared a minus sine squared of a. Should be a minus in there. Minus sine squared of a. So we still can go back to that, but we utilize that to be able to derive these two formulas. Making our same substitution, we have the cosine of 2 1/2 x is equal to 1 minus 2 sine squared. I'm going to write it once again as x over 2. The 1/2 and the 2's once again will cancel out here. Subtracting 1 from our now before we even do that, I'm going to go back to my old adage here. We have cosine of just the value of x is equal to 1 minus 2 sine squared x over 2. And we can use my old Gregoryism that I've coined. We're going to do a double switcheroonie. We're going to add the 2 sines squared over here. We're going to subtract the cosine of x over here. So we're left with 2 sine squared x over 2 is equal to 1 minus cosine of x. We divide by 2. Now we're exact same thing as we did before. Sine squared of x over 2 is equal to 1 minus cosine of x over 2. square root, square root. We're left with the sine of x over 2 is equal to plus or minus square root of 1 minus cosine of x all over a value of 2. They're very similar in form. Very similar in form. The cosine is a plus cosine here. The sine is a minus cosine over here. But everything else is the same. And once again, you'll be expected to know that. We can look at the tangent of half x is a sine over cosine. So we have plus or minus square root of 1 minus cosine of x over 2. And then we have plus or minus square root of 1 plus cosine of x over 2. We can simplify this underneath one radical. And if we use our complex fraction idea, multiplying top and bottom by a value of 2, they will cancel out. So we have 1 minus cosine of x over 1 plus cosine of x. So there's your tangent of half angle, which is just your sine over your cosine. Now, we can do two different alternate forms for the tangent of half x. This is fine to utilize this, not a problem. But if we would take this and multiply top and bottom by 1 minus cosine of x, 1 minus cosine of x, we are left with 1 minus cosine of x squared. And then if I would FOIL this out, it's sort of like a conjugate, we have 1 minus cosine squared of x. If we remember back to our trig identities we just worked on, 1 minus cosine squared is equal to sine squared. So we're left with the square root, 1 minus cosine of x quantity squared over sine squared of x, squaring square root, or square rooting squares, we're left with 1 minus cosine of x over sine of x. That would be an alternate way of utilizing. We could do the same thing by multiplying top and bottom by 1 plus cosine. And what will happen with this is this will just turn into sine squared on, or sine of x on top, and then 1 plus cosine of x on the bottom. All three of these will give us tangent of half x. I tend to sway towards this one here. And how I remember it, I just remember sine over cosine, so we have negative over positive. And then the negative will be, or we'll have that on top, and then the bottom will turn into your sine of x. Okay, you can utilize either one, does not matter, but you once again will be responsible for them. Okay, if we look at sine of pi over 8, okay, maybe in your best interest to take your 180 and divide it by 8. And you get your 22.5. Since we're using half angle formulas, we're looking and we're asking ourselves, what can we take half of to get the value of 22.5? And we can say this is a value of sine of 45 divided by 2. And we would be able to calculate using our half angles. We're looking at sine. Still go back to our 30/60 and our 45/45. One square root of 2, 30/60, 1, 2, square root of 3. We'll need that for the tangent. And the next problem, if we take a look at the value of 45, we can rewrite this as plus or minus the 1 minus cosine of 45 divided by the value of 2. Remember, when we're dealing with sine, this is a negative sign. So substituting in, we have plus or minus square root 1 minus square root of 2 over 2 over 2. And we can multiply top and bottom by the value of 2. Leaving us with plus or minus square root of 2 minus square root of 2 over the value of 4. We can take square root of 4. Take square root of 4, we get the value of 2. We're left with plus or minus square root of 2 minus square root of 2 all over the value of 2. Now we have to make a decision. Is it a positive or negative? Well, we have 22.5, which is in quadrant 1, and anything in quadrant number 1 will be positive. So this will be a positive value here. If we look at tangent of pi over 12, when we take our 180 and divide by 12, we get a value of 15. Now I know we dealt with 15 with angle addition. We can also deal with 15 in half angles. So we could take the value, this is the value of 15. We can write this as a tangent of 30 divided by 2. And use our tangent half angle formulas once again. Sine over cosine. You can use any of these. But what I will use is the first one we developed, and I will utilize this a little bit more. Where we have the value of 30, the value of 30. So we have the cosine of 30, which is 1 over 2. And then we have the sine of 30, which is square root of 3 over 2. Multiplying both top and bottom by the value of 2. We have 2 minus 1 on top. On the bottom we have square root of 3. So we have 1 over square root of 3, which rationalizes square root of 3 over 3. The nice thing about this is the positive or negative side will come out in the wash for you, and you won't have to make a decision where you're at. If you use the other formula where we have 1 minus cosine of x divided by 1 plus cosine of x, it's going to give you a radical within a radical. The cosine of x is 1/2. So we have 1 minus 1/2 on top, and then 1 plus 1/2 on the bottom. Square root of that. Once again, multiplying everything by 2. We have 2 minus 1 on top and 1 plus 2, or 2 plus 1 on the bottom. Now we'll take us back to 1 over square root of 3 again. Either way is correct. If you have the cosine of 112.5, this would be 225 divided by 2. Which now we're going to have to do a little bit of work. 225 takes us into quadrant 3. So we can do 225 divided by 2. Cosine is going to give us a plus on top. So we have plus or minus square root of 1 plus cosine of x divided by 2. This is 225. So if I look at the cosine of 225, we have a negative 1 over square root of 2, or we have plus or minus square root of 1 plus a negative square root of 2 over 2, all over a value of 2. We can simplify once again by multiplying top and bottom by value 2. So we have plus or minus square root of 1 plus a negative, 2 plus a negative square root of 2 over a value of 4. Take square root of top and bottom. So we have plus or minus square root of 2 minus square root of 2 on top and 2 on the bottom. Now we can clickety-clack into our calculator cosine of 112 to determine if it's positive or negative. Okay, it puts us into quadrant number 2, and in quadrant number 2, we have a negative over a positive, so the cosine will be a negative. So this is a negative value. And lastly, sine of 22.5. Rewrite it as what can we take half of? And you can refer back to the first one up here where we did cosine of 225 or sine of 22.5. Now we're just doing sine. So we rewrite it. 45 divided by 2. Expand out your half angle for your sine. Once again with the sine, plus or minus, square root. The sine, we have the minus on top. 1 minus cosine of x over 2. We have square root of 2 over 2, multiply top and bottom by the value 2. It's the exact same thing we've done in about every one of these problems here. Oops. Plus or minus 2 minus square root of 2 over 2 times 2, square root of 2 times 2 is the value of square root of 4, which takes us back to the value of 2. Once again, sine 22.5 is in quadrant number 1. Everything in quadrant number 1 is positive. So we have a positive there. Sorry I missed a few days here. Hopefully I'll be back on Thursday. That's my goal, but I can't guarantee anything right now. If it's not Thursday, it will be Friday, hopefully. But I appreciate you working with this, and you probably enjoyed a couple days off because the festival requires too. So hopefully I'll be back a little bit. We'll be back soon. This is your lesson for your half angles. Have a good day.